okay, we're going to fit this model, and the model will contain a test in it that we can see if that's valid. So we fit the model. Now we get this likelihood ratio, chi-square of 100, 2 degrees of freedom. All that tells you is that the coefficients of u and u squared are not both 0. I mean, that would just say there's no effect of fat level. I mean, it's obvious that there's an effect here.
Right.
So I skipped that. So now on page 12, the model has 8 intercepts, and when the first time students see this, they say, what? 8 intercepts? When you do a ordinary regression, you get an intercept. You do a logistic regression, you get an intercept. Here we're getting 8 intercepts. And then we get a coefficient of u and u squared. So you can see that the estimated coefficient of the fat level is 33, and the estimated coefficient of u squared is a minus 115, which is pretty much in the middle of those values on page 10. It says the log of the probability y equal to or less than 1. Mm-hmm. That whole thing, this is the theoretical model on the right-hand side. What we have to do is estimate that alpha, that beta 1, and the beta 2. Now we've got a model. We know the assumptions are satisfied. We're not violating any statistical assumptions as we did in the regression. Questionable things. And we can now, we've got another equation that we can differentiate, maximize, and when we do that, we find we get 0.1437. Remember what it was before?
0.144 something like
yeah,
that.
It's almost the same answer. So one of the dangers of this is going through and say, you mean you went through all this work and you get the same answer? And I say, well, it's nice to know in some sense that you do get about the same answer. But I use this, 0.1446. Yeah, it's almost the same thing. I mean, you're going to go out to the 3rd and 4th decimal point before you get a difference.